Big printers, little printers, red printers, and blue. Some print with string and others print with goo. They all move in different ways. The question is, which printer is for you? Hello, in today's video, we're going to be talking about some things you should be looking out for when you're purchasing your first 3D printer. Now, I've been making 3D printer related content for a little while now, and over that time I've received many questions from people asking what machine or what kind of machine I should get as my first 3D printer. So in today's video, I'm going to try and answer some of the very common questions that I receive on things you should be looking out for and things you should avoid when looking for your first printer. Now, a lot of my opinions in this video today are based on personal experiences, and I understand that not everyone will agree on everything I have to say. So if you do want to discuss anything that comes up in the video further, please ask those questions in the comments below. And of course, after you've decided on a 3D printer, you're going to want to print some things. And if you're looking to print some things, why not Thangs? Their site has over 3 million models and growing, and more on them later in the video. Now, the first thing you have to ask yourself is, why do I want a 3D printer? Are you getting one for work or for school purposes? Do you do a lot of D&D and you're looking for something that can print models for that campaign that's coming up? Are you a CAD designer and you're looking to make prototypes of things you are actively designing without having to go through a machine shop, for example? Are you into cosplay? Or you like making props from movies at home? Are you a hobbyist who enjoys working with electronics and building stuff and you want to build your own machine at home? Or did the YouTube algorithm just recommend a video from some nerd printing a hairy lion and you thought that was kind of cool and you want to do that yourself? Regardless of the reason, you're going to have to take that into account when deciding on your first machine. Now at this point, you're going to have to make your first choice, whether you want to get an FDM or filament-based machine or a machine that prints using resin. So between those two types, personally, I'm really going to recommend for a first machine, for the vast majority of users, you're going to want to get a filament or FDM-based machine. I'll mostly be speaking about FDM-based machines today, so I'll just touch on resin printers quickly at the start here. While resin printing is capable of producing extremely high quality detailed models, the process is a lot more involved than FDM. There is much more post-processing to the models after they are done printed. You have to clean them, you have to wash them, you also have to cure them. Handling uncured resin requires that you wear gloves because they can be toxic. And for the most part, the use cases for a resin printer are a much narrower field than with an FDM-based machine. While an FDM machine can do a lot of things that resin printers can also do, a resin printer has a more narrow use case. So really, unless you plan on getting into 3D printing because you are looking to print models for an upcoming D&D campaign, or you want to make your own 40K models, or just any other reason that you need super high quality detailed models, I really only recommend getting a resin printer if you know that the main use of your printer will be printing things such as high quality detailed minifig models for painting, for example, or any other high quality, high detail models for any other use case. Now, filament based machines are much more common, and those are the machines that I'm going to be spending most of this video talking about. So personally, I recommend for your first machine getting an FDM or a filament based machine. You're going to find you're going to be able to do more with the machine, and there's many more options out there for FDM machines. And also, if you want to print larger things, resin machines at the larger print volumes do get quite pricey quite quick. However, you can get larger FDM machines for a quite reasonable price. So after that, you need to decide if you want to build your printer or buy your printer. And this is a very common question I get. Should I build my first machine or should I buy my first machine? I'm going to answer this in a few ways. But for the most part, I recommend that you buy your first 3D printer, especially if you are brand new to the hobby. There are several reasons for this. First reason is if you are new to the hobby, your electronic skills aren't the greatest, you've never built a 3D printer before, setting up a commercial off-the-shelf printer is usually much simpler. Most of the electronics, the wiring and assembly, for the most part, is already done. You may just have to do something simple, such as attach a gantry, cut a few zip ties, and plug in some wire bundles. This will make the setup process and getting to that first print much more simpler and more streamlined. Also, with a commercial machine, the odds of a first-time user running into any major issues are significantly less than if you built your first 3D printer on your own. Other advantages are also when you buy a machine, if you find out that 3D printing is not for you, it's usually easier to sell a commercial printer than a printer you built yourself. So what machine should I buy? Well, this really comes down to why you're getting into 3D printing and your budget. If 3D printing is just something you kind of have a interest in, you've seen a video on YouTube or a few pictures on Reddit, for example, and you think that's something you're going to want to get into, I would recommend buying something on the lower end of the price range just to get your feet wet in the hobby. There are multiple different printers in this category. The most common one you'll most likely see though is the Ender 3 V2, and I would recommend that as a very good entry-level machine or a similar type machine. Now, the Ender 3 V2 has been around for a little while now, and there are cheaper options and options with more features. However, I still stick with recommending that machine for multiple reasons. One, it's at a price point where if you decide that the hobby is not for you, you're not losing out on too much, and you should be able to sell the machine for half to a little bit more of your purchase price on a local marketplace. At least that's what I've seen online. Also, for an entry-level machine, it's been around for a while, and that means there is a large community around the printer itself. Odds are, if you run into any issues with it, others have run into those issues, you're going to be able to find frequently asked questions, tips, and tricks from many of the communities are based around this printer. Now, the Ender 3 has a lot of clones and derivatives out there. For the most part, you're going to find a lot of V-wheel based bed flinger style printers at this price point. Some of them have more features such as bed probes and removable flex plates. Others come in at a much lower price than the Ender 3 V2. Now, I do want to caution with purchasing lower priced entry-level printers that you wait until actual consumers have these printers in their hands before purchasing one and basing your opinion on buying the machine based off their experiences with it. Unfortunately, it is a common thing that I've seen where reviewers get models of these lower price printers that are actually built to higher quality control standards and sometimes with even higher quality components than production machines. So if a brand new printer out on the market has a much lower price point than the rest and a bunch of glowing reviews, but it's only been out for a week and nobody actually has their hands on production models, you may want to hold off on jumping into that boat, at least until you make sure that everything is okay with it. Now, of course, you don't have to start on the lower end. If you are looking to get into 3D printing for something like work or school, or you know this is going to be a hobby you're going to be doing for a while, in these cases, machines that have support are going to be key. So if you're buying a machine for, say, work or for a school purpose, you're going to want something that is certified, has UL or CSA approval, electrical certifications, whatever the EU requires for safety, and you're also going to want a machine that has something like 24-hour support. Nothing is worse than the machine going down that work depends on and you're not able to get easy parts or customer service. In this category of 3D printer, you're going to be looking for companies that offer 24/7 support, companies that are able to provide replacement parts on demand. You're looking for a company that will be able to basically service this printer if you run into issues. You're not expected to be ripping this printer apart and doing upgrades or mods to get it to a functional state. And of course, there's also printers in between both of these extremes. You may be able to get a printer that's more bang for your buck if you're okay with doing support and maintenance and potentially doing a few mods to make sure the printer is functioning properly. It really comes down to personal preference. I highly recommend just seeing what others are using as their machines and checking out a few printer groups to see what others recommend in these regards. Now, of course, if you don't want to purchase a machine, you can always build one on your own, and there are multiple different options when it comes to building your 3D printer. And this is really going to come down to personal preference on what you're looking to get out of the machine and what you're looking to do with the machine. You have multiple different options. You can self-source or you can purchase kits. Some established printer companies, for example, like Prusa, sell their full printer as a kit that you build completely yourself. This allows you to have the whole experience of building the printer, but you also have all that extra support that comes from buying a commercial product. Now, on the opposite end, you can source all the components yourself and build the printer on your own. Now, there's multiple different options when it comes to open source printer designs. Personally, I myself am a fan of Orons, as you can see, but there's also options such as Railcores, Hevorts. There's many designs out there, and some of the newer ones are quite capable machines that you can build for a much lower price than some of the higher end commercial machines and get much better performance out of them. Of course, if you're okay with taking all the maintenance, assembly, and troubleshooting work onto yourself. When it comes to choosing a DIY printer build, I recommend take a look at the communities around the printer. How good is the documentation for that printer yourself? Are you only going to have a few pictures on Thingiverse, a few videos, and a comment that you have to go hunting for as your only guide for building the printer? Or does the design come with a fully illustrated manual, wiring diagram, and example firmwares, for example? You're going to find a wide gamut of different quality of documentation, of instructions. Some don't even come with complete bills of material. Others have complete sourcing guides. There's really a plethora of designs out there, and you could spend days hunting down which one you want to do. Now, after you've decided on whether you should build or buy your printer, your next choice is going to be how big of a printer you want. And it's a very common pitfall to buy or build a printer that is bigger than you need. I myself fell into this trap, and the very first printer I built after my Monoprice Select Mini was a 300 by 300 by 400 Voron V1.5. It's very easy and very tempting to go big, but going big can have a lot of problems and a lot of downsides. For example, if you're only going to be printing smaller objects, purchasing a big printer can be a waste. One, in cost. Larger printers are usually more. Two, you're not going to be able to run these machines usually as fast or as hard as smaller machines, depending on the kinematic. Now, some printer designs such as Core XY, cross gantry, square frame printers are usually more robust. They can usually go bigger and go faster than some printer designs such as a V-wheel i3 Cartesian bed flinger style printer. With those, as you get larger, the beds get heavier, you're printing larger objects on the bed, and it's constantly moving front to back. So you're going to have all that moving mass changing direction quickly, and the mass isn't going to be consistent throughout the print. Also, with a bed flinger style printer, for example, as you print up taller and taller, you have the chance of the print itself actually swaying back and forth. Larger machines, for the most part, you're not going to be able to run them as fast or as high accelerations. Now, this may not be a criteria for everyone. Not everyone needs to print fast, and not all filaments can print fast. If you like printing with silk filament, for the most part, you have to print quite slow to get that shiny effect out of it. So when it comes to size, take note of what you are going to be printing and get a printer that is sized correctly for that. Even if you want to do something such as printing helmets, a lot of the times you can find models that are cut into pieces, or you can separate them yourselves and then print them and reassemble them afterwards. There are actually many advantages to doing this, as depending on the model, it may be more advantageous to print it in parts, as you'll require less support and you'll be able to print certain details at the correct orientation to get better quality or better strength out of those details. I really recommend for a first printer sticking around the 230 to 250 millimeter cube as your starter size. This is roughly the size of a Prusa Mark III or an Ender 3's print volume. And since those are very common sized machines, you're going to find a lot of models that already fit within that print volume. If you go smaller than that, you may run into issues with running out of room quite quickly, especially on smaller machines. And if you go larger than that, you may find yourself with a printer much larger than you need. Remember also, with these larger machines, if the bed moves in the y-axis, you have to have enough desk space available for the bed to move all the way to the front and all the way to the back, with potential drag chains and cables hanging out of the back. So if you don't have a large area, you may want to look into a smaller printer, or a printer with like a box frame design where the bed moves on the z-axis, as this will be a more compact package. Another common thing to look out for when deciding on what type of 3D printer to get is how the filament is fed to the hot end. Do you want a direct feed setup, or do you want a Bowden feed setup? On a Bowden feed setup, your extruder is usually attached to a gantry or the frame, and the filament is pushed into the hot end through a Bowden tube. On a direct feed setup, your extruder is on the tool head, and the filament either feeds directly into your hot end or through a very small filler Bowden tube between the two. Personally, I am a fan of direct feed setups on most machines. However, this isn't always a practical use case. On some of the lower end machines, such as the Ender 3 V2, you only have one lead screw on the Z-axis. What this means is, as the tool head moves across the gantry, there's really nothing to hold the gantry up on the other side other than friction of the V wheels. So if you go with a direct feed setup on a printer of that style, you can actually have the gantry sag from the increased weight of the tool head. And also, with that increased weight on the tool head means more moving mass, so you may have to slow down your speeds and feeds with a direct feed setup on some machines. Now, if your machine is rigid enough, or you are okay with printing a little bit slower, direct feed setups do have many advantages as well. Since the filament feed path is much smaller, usually tuning these printers and getting higher quality prints out of them is a little bit easier than tuning with a long Bowden tube. Filament in a Bowden tube can be springy, and also depending on how soft the filament is, if you're printing with something soft like TPU or a flexible filament, printing that over a Bowden setup can require either extremely slow sprinting speeds or may not even be possible at all. And then also how your extruder pushes the filament comes into play for both of these setups. You will find a lot of lower end machines have an extruder that is simply a straight tooth feed gear with a smooth bearing to push against, and this is all that's pushing your filament. Now personally, I find these setups of a straight tooth direct drive extruder as a very basic and very lacking design when it comes to extruder. Since the teeth are straight cut and the filament is round, you're going to have a high pressure contact with the filament. You're going to find grinding to be a common issue, and you're not going to get the most friction and grip on the filament itself. So if you're doing something like printing filament such as PLA with a low temperature resistance and your motor gets hot, because it is direct drive, that heat from the motor can transfer into the drive gear. And because the drive gear is straight tooth and it's cutting into that filament, if you're doing something with a lot of retractions, you can actually grind away the filament quite quick. And I've seen the filament almost semi-melt in this kind of case. On some higher end machines, or if you're okay with doing the upgrade yourself, going to something with like a dual drive setup where you have curved feed gears on both sides of the filament pushing it through, and also a setup that is geared. This gives you much more torque and removes the issue of heat transfer, can give you much more high quality results, and usually is a little bit more reliable as well. However, personal experiences can also impact these design decisions. If you have, say, an Ender 3 V2 or a printer with the stock extruder setup, and the filament you're printing with and the models you're printing don't run into any issues, you may not need to upgrade. However, if you are getting one of these machines for something such as printing flexibles constantly, you may want to look into a machine that already comes with these features, or look at upgrading this yourself. Now from the extruder looking at the hot end, you're going to be looking at nozzles and the heat break. In my opinion, the nozzle and heat break are two of the most important things on a printer when it comes to print quality. You're going to find very commonly a PTFE lined heat break, especially on lower end machines. So PTFE is a very slick plastic, and you'll find PTFE heat breaks are lined with it specifically so that the filament doesn't stick as it travels that last little bit that's heated before the nozzle. It is much easier to get a higher quality print out of a lower end hot end with a PTFE liner than with an all metal one. Now the downside with PTFE is it's the same thing as Teflon cookware. You're not supposed to get it past a certain temperature. It's a little off-gas, noxious, and toxic fumes. PTFE, same thing. Usually what you'll find is most people recommend that if you're printing below 240 degrees Celsius roughly, you're okay with PTFE. But if you plan on printing higher temperature materials with your printer, such as ABS, polycarbonate, or nylons, you're going to want a all metal hot end. With an all metal hot end, it replaces that bit of PTFE with just simply having the entire heat break made out of a metal of some sort. You can find ones that are stainless steel or titanium. I like the titanium ones, but if you go with an all metal hot end, make sure it is of a higher quality. You do not want to buy cheap all metal hot ends, as if the internal finish of the heat break is not very smooth, you're going to have a lot of issues with jamming and heat creep, as the filament's going to get stuck in there. The nozzle is another key point of your hot end. With your nozzle, this is where the filament comes out and will impact print quality a lot, and also can be affected by what you're printing. The nozzle is another thing you need to keep in mind. Brass nozzles are very common, and you'll find most printers ship with those. Brass nozzles are great because they have good heat transfer, so they'll get the heat from the heater block and transfer it into the filament quite well. Make sure you use nozzles that are higher quality, because the internal machining of it and the actual hole in the nozzle itself that the filament comes out will definitely impact print quality and print reliability. Now for most users, brass is fine. However, if you're going to be printing things that are abrasive, you're going to want a hardened nozzle. So these are nozzles made out of steel or other hardened materials. I'm of the opinion that unless you plan on printing abrasive materials, really don't need to go with a hardened steel nozzle. There are many different nozzles out there to choose from. For example, the E3D Nozzle X. On my machines that I do run abrasive through, I do use those nozzles. You can also upgrade a brass nozzle for softer plastics to something such as a copper plated nozzle. Copper transfers heat much better than brass, and with a plating on it, this can help reduce plastic sticking and building up on the nozzle. So on my machines that I personally run non-abrasive plastics through, most of them run a copper plated nozzle on them. 0.4 millimeter nozzles are, for the most part, the most common nozzle you're going to see out there, and most machines ship with that. You can buy nozzles in different sizes, so if you plan on printing big things, you can go with a bigger nozzle. If you plan on printing smaller detailed models, you can go with a smaller nozzle. This is all personal preference. And the last big thing I'll talk about is beds. When you're printing, your print has to stick to the bed, And then when you're done printing, you have to be able to remove the print from the bed. There are multiple different options for bed surfaces with printers. In this day and age, I recommend that you do not buy any printer that does not come with a heated bed. For the longest time, entry-level machines did not come with heated beds. We're past that point now. If you're buying a printer without a heated bed in today's day and age, you really shouldn't be doing that anymore. Get a printer with a heated bed. And the bed surface is going to be key as well. And it's really going to depend on what price point you're looking at and what you are going to be printing. On the lowest end, you're just going to find an aluminum or PCP bed with sometimes a build tack or a skateboard tape kind of looking material on it. Some even come bare and you have to use something such as a glue stick or painter's tape on it. This is about the lowest end of bed surface you'll find. Upgrading from that, you're going to find a glass bed with a carborundum surface on it. It looks kind of like a carbon fiber material. Personally, I'm a fan of glass beds on lower end machines, simply for the fact that the beds on the lower end machines, for the most part, are not the flattest. So attaching a slab of glass to it can help a lot with making sure that first layer is good, as you'll have a flatter surface to work with for the most part. These carborundum bed surfaces work pretty good for most plastics attaching to them. Just make sure that when you remove the print from these beds, the print is fully cooled. If you try to pry off a print off a carborundum bed with it still being hot, you can actually damage the bed. And my personal favorite for bed surfaces is a flex plate bed. These can have multiple materials on it. I'm a big fan of PEI. You can get textured or untextured PEI. That's personal preference on how you want the finish on your print to look on the bottom. But flex plates are great. They allow you to remove the print out of the printer, flex the plate, and the prints for the most part come off right then and there or with minimal prying afterwards. I really like flex plates on machines. On lower end machines though, I recommend that you only put a flex plate on it if you have some sort of bed or nozzle probe. Reason for that is once you add a flex plate, you're also adding layers of glue, a magnet, and adhesive along with the flex plate and its surface. You may not have as true flat of a surface to work with. Having a bed probe allows you to compensate for any potential inconsistencies this sandwich of materials will add to your printer. And bed probes are another thing to talk about. Not all machines come with a bed probe. Many machines you have to manually level. This is easier to do on smaller machines, so if you are looking for a machine that comes without a bed probe, you may want a smaller one, as you have to manually adjust usually the four corners of the bed to tram out that bed surface to the gantry. There are many different options out there when it comes to bed probes. For the most part, they all work quite well, and again, this is a 3D printer. We are basically using a glorified hot glue gun to lay down layers of molten plastic. Most of these options are accurate enough that you're really not going to see too much deviance in those first few layers. Now, of course, deciding on what kind of 3D printer and what's in it isn't everything. You need to decide on what you're going to print with it. And if you're looking for 3D models, why not check out Thangs? Many of the models featured in today's video are from Thangs.com, and I want to give them a huge shout out for sponsoring today's video. Thangs' selection of 3D models is growing daily, with currently over 3 million models to choose from. With the ability to view whole model assemblies in exploded view, search geometrically by an existing model, or view your model in augmented reality on your phone, Thangs is sure to become your one-stop shop for anything you need. This, of course, isn't everything you should be taking a look at when it comes to purchasing your first 3D printer. The motion system of the printer itself comes into play. Whether you plan on enclosing your printer or not is another thing you may need to keep in mind. There are many more things that we can look at, and if you want to see a part 2 of this video, make sure you ask for what you want me to cover in the comments below. I hope you enjoyed today's video. On the way out, make sure you like that smash button. If you want to help support the content I create and the things I do, I have links in the description as well. I hope you learned something new, and as always, have yourselves a great day. Cheers.